How are you doing today? Hopefully you're doing all right. This is Mr. Myesis. I'm here again with another video for how do you use Geogebra. We're doing some stuff on Geogebra using some statistics. So we're going to look at linear regression and using Geogebra to figure out some linear regression, to find your R squared, and we'll talk a little bit about interpreting some of that. And then we'll also look at how to make a prediction using Geogebra. So let's take a look. Let me shrink myself down here. All right. So I have these data here. So let's suppose student measure their height and wingspan. Wingspan is like this. You can't see if you look at the video on the little me on the corner there. You can't see my whole arms because I got a large wingspan. Not really, just because there's not a large screen. Let's suppose we take a random sample of 12 stat students, and we're going to put these into Geogebra so we could find a scatter plot. So let's go ahead and do that. So you're going to go to Geogebra and geogebra.org, and I like Geogebra Classic. We do Classic here, and we want the spreadsheet. All right, and then I'm going to enter in my data here. I already had them ready to go. So I'm going to have my height data in column A and my wingspan in column B, because what I want to eventually do is predict the wingspan based on height. So you have to know which one is going to be your response and which one's going to be your explanatory variable. And your explanatory variable is, or your independent variable is going to be on your x-axis. So that's going to go first in Geogebra, because you can't really, you can't label the columns. All right, so we're going to, once we have these in here, we're going to highlight both of them. We're going to click on the little histogram in the corner like we've done for many things in the past. And we're going to do two variable regression analysis. So click on that guy. There we go. All right, so now we got a nice scatter plot here. Column A being my height and column Y being my wingspan. All right, so now what? Now what you say? I like to do this summary statistics just so I could have them on the side. I'm going to move this over here so I can see them a little bit better. All right, so I have my means and my standard deviations. And look, there's my R. So my correlation coefficient is 0.81, 0.817. It's pretty good. So we would say that these data are pretty strong, right? Because we've got a pretty good correlation coefficient. All right, down here we see regression model. All right, so this is where we're going to put our line of best fit, or our linear regression. Now Geogebra allows you to do all these types of regressions. In this course right now we're only looking at linear, so we're going to click on linear and it draws our line in there. Awesome sauce. Not only that, but it gave us our equation. Y hat, we need a hat there. It doesn't put a hat, but you should put a hat. Y hat equals 0.8247x plus 11.7448. So there's our equation. Now, if we want to use our equation to, so what do we got here real quick? We've got a slope of 0.8247 and a y-intercept of 11.748. So if we were going to interpret these, right, we would say that it's really weird, but if somebody had like 0 height, they would have an average, we would expect them to have an average height of about 11.7 in wingspan. Weird, but okay. For the slope anyway, the slope would be for every inch, these are in inches, yeah, these are in inches. So for every inch in height that we add on to a person's height, so for every additional inch in height, we would see we would expect to see an average of 0.8247 inches in an increase in wingspan. So we want to be specific on, like, we expect it, right? Because this is just a prediction. We want to make sure we talk about for every unit increase of the x, we're going to see the slope amount increase or decrease if it was negative for, in this case, the wingspan. All right, so suppose we have somebody come up to us and say, hey, yo, I want to know how, I don't know why I don't know why Rocky in particular is asking, but hey, yo, I want to know what my wingspan is. Let me know. And he says, I'm 68 inches tall. So he already knows his height in inches like everyone does, right? So you go, okay, 68 inches, I could do that. I have my formula right here. Geogebra says, okay, I could do it. Put in x. So I say x is 68. GeoGebra says, do it again because I didn't know what you're talking about. So 68. And then you say to him, yeah, well, I predict that your wingspan is approximately 67.8264 inches based on my mathematical model. And that's it. So that's how you do that. Now, the guy says, well, I don't believe you. I actually did it when I was at home, and it turned out to be 70. I'm 70-inch wingspan. And then you would say, well, this is a prediction. It's not exact. I'm predicting it based on the data that I have. And so I am going to be, let's see, I'm going to do the math real quick. 70 minus 67.8264. I'm 2.17 inches off. I just subtracted what he told me his actual was minus my predicted, and I got 2.172. So that is called a residual. So the value between what actually happened, so what he told me was, and the value that I predicted, the difference between those two is called the residual. Now, in this case, it's a positive residual because his actual height was more than what I had predicted it to be. If it was a negative residual, then his actual height would have been less than what I had predicted to be, meaning I overestimated it. So that is how we use GeoGebra to make some predictions and to find all of the values that we need for this. Now, notice here I did want to say a couple more things. R squared shows up, so now you have R squared there. And if you want to look at a residual plot, you can always click this little down arrow and it'll show you the residual plot, showing us that since these residual is scattered and there's no pattern, then our linear model is appropriate for these data. All right, so there you go. That is GeoGebra and linear regression. Well, I just want to be bigger now. Catch you next time. Don't forget to subscribe.